Welcome to Text Analytics 201, a podcast by Indium Software. The global market for text analytics is expected to grow by $14.23 billion between 2021 and 2025, delivering a CAGR of 24.71% during the forecast period. To go deeper into analyzing the trends and opportunities in this space, we put together this podcast featuring Mahesh Belli, Head of Brand Marketing at Indium Software, and Ashish Kumar, Principal Data Scientist at Text.ai, a text analytics product by Indium Software.
Hello there. Welcome to the State of Text Analytics podcast from Indium Software. This is Mahesh Belli, Head of Brand Marketing, and we have with us Ashish Kumar, Principal Data Scientist at Indium Software, a thought leader, author, and one of Analytics India's Insight Magazine's 40 under 40 innovator. Ashish, welcome to the show.
Thanks, Mahesh. Thank you for the introduction. Nice to be here. Excited for the discussion ahead.
Right. Folks, the topic under discussion today is Text.ai for healthcare and life sciences. For those who are just getting introduced to Indium Software, we are a digital engineering company with 2,000 plus associates working across the globe. And Text.ai is Indium's text analytics solution, also recognized by Forbes as one of top 25 machine learning startups to watch in 2020. So let's get started. So Ashish, text analytics has been in the market for a while now, and there are many commercially off-the-shelf solutions, but customers seem to face roadblocks in adoption. What seems to be the problem?
Yeah. So, nice question to start the discussion. You rightly said there are a lot of solutions in the market which claim to be ready to use. But the problem is in the NLP market, there are a lot of problems to be solved. So NLP, as you would know, is not a business segment. It's a technology which solves problems across different businesses, across different domains, right? So every industry you enter in, they have a different use case for NLP. It's very different for BFSI. It's very different for healthcare. So every industry has a very niche use case for NLP. So it's very difficult to build a solution which will cut across industries, cut across domains, or even departments or functions in the same company. One problem is that, like, many people have been trying to build solutions which would cut across these industries, one solution for all, right? But that's not very feasible. That's very difficult to make just because there are too many use cases. So that's one of the problem, too many use cases. Second is that NLP is a technology which derives itself from ML and AI. So that requires a lot of training. NLP gives you the most advantage when you train it on custom data. The paucity of custom data, like not many companies have a lot of data to train on, except the enterprise technology company which collect a lot of data from our usage. Suppose a startup wanting to build a model, right? They don't have the luxury to have enough data to train a very good model. So that is another problem. Like, there are many custom problems, but to build custom solutions, you need a lot of data. That's not there in abundance, especially with small sized companies. Enterprises, it's a very different game. So I think these are the two main roadblocks, I would say. There are too many use cases, too less data to solve those problems.
Right. So what we're hearing is NLP, natural language processing, is a very powerful tool that has come out of the AI segment. Just that because the amount of customization that is required for individual verticals, there is no catch-all solution for all problems, right? So
Correct.
How does Text.ai from Indium Software address some of these concepts? And it'll be good if you can share some information about the solution as well for our listeners.
Correct. Yeah. There's something called transfer learning, right? Where you train for some task, train a model for performing some task, and then you can reuse some part of it for doing another task. Like there is a concept called word embeddings, or it's not limited to only words now. Basically, you convert words or like a sentence to a vector embedding, which is numerical, and you do that using different frameworks of neural networks which are available. So once you do that, those embeddings can be reused for different tasks. So that's called transfer learning. So and that can take care of your, let's say, 60% of your training, and then 40%. These are rough numbers, like it won't apply to all the use cases, but on an average, you can say 60% of tasks can be learned, and 40% is what you need to retrain on. So what we have built at Text.ai is that this 60% time, if a new use case, we are given a new use case from a different industry, like we can save this 60% time and only take the rest of 40% time and give you a very good solution in a very limited. So we are reducing the time to go to the market for NLP solutions. So that's why we call ourselves an accelerator solution. Like you come to us with a problem, and we will give you a customized solution which will solve your problems, but we will take only 40% of time, which it will take for you if you were to make a solution from scratch. So that's what we promise.
Excellent. That sounds fantastic. So as a part of this discussion, we want to get in depth about text analytics and how it can help in healthcare and life science industry. Before that, can you share what you see as some of the top use cases in this industry?
So there are many use cases in healthcare, and different kinds of players are targeting different. We can tell from our experiences and based on our discussions with potential customers, what is the solution people have been asking for quite frequently. So one is starting with EMR, right? Electronic medical records.
Correct.
So that is captured in different ways. Sometimes it's captured as audio data. Like we have a customer, they record the client-patient interactions, and a client patient-doctor interactions, and then they want to generate EMR out of it, because patient-doctor conversation is very free-flowing, right? So how do you so they go with audio because it's easy, like there is no need of an assistant or doctor to scribble notes during the conversation. So they do a free flowing conversation, audio is recorded, and then we transcribe that using a voice to text module that we have custom built for this application. This was an example of transfer learning that we did. If they had to train model for this from scratch, converting voice to text, it would have taken them a very long time. At least I would say at least a year to build the framework that we built for them, and at least millions of hours of data. But we were able to build a solution for them with 90% plus accuracy within 2 to 3 months, and with a fraction of data, with just I would say just 1,000 hours of data. Coming back to the use case, so we don't just stop at transcribing the audio data. We after transcribing, we structure it. When patient and doctor talk, they talk about a lot of things like what is the medical history, or what current situation the patient is facing, and what is the diagnosis, early diagnosis by the doctor, what are the prescriptions, and so we categorize that transcribed text in these sections, and then we create a report, and that is our final output. So we start from an audio file and we give this structured EMR record for that interaction. So that is one. So there are many use cases around EMR. This is one. Second is there is a lot of need for there's something called ICD codes in US, which is basically a code for each disease or each diagnosis. So mapping the diseases to code, ICD code, because that is when it becomes processable for downstream things like claim processing, insurance claim processing, or getting all the benefits from your insurance. So that is a must to do things on EMR records before it goes. Today it's done manually. So we have a lot of customers, and we're doing it for one customer. It's a challenging problem because there are many diagnoses mapping to same ICD code. There's one to many, many to one, all kind of relationship between them. So it's a challenging problem. So many people are trying to solve that. And third is because healthcare is very private, privacy sensitive industry. So, for example, clinical trial companies have been asking us to build a redaction solution, and we have built it for them, both manual and automated redaction. So, and there are a lot of protocols to how to do redaction, like color codes, like the commercially sensitive data or personally sensitive data. There were different color codes. So we have built both manual and automated solutions to do redaction. So yeah, I would say these are top 2-3 use cases coming out of healthcare industry right now.
Right. A lot of conversation around these use cases, opportunities in the medical field, but then there are problems. There are regulations and data privacy as well, which seems to be a huge concern in this industry, perhaps more so in the healthcare and life sciences because of simplifications. What are your observations? What's happening in this market because of these regulations and data privacy constraints?
So first and foremost effect is that see, there is a trade-off between privacy and usability, right? You're trying to build a machine learning model which will ease the job of a person or a company. It will save cost for a company. Like the ICD code mapping example I was giving you. Right now it's done manually, it takes a lot of time. If there were a machine learning solution, perfect machine learning solution, it would save a lot of time. That's what we're trying to build, it requires a lot of data, right? But EMR data is very sensitive. Many companies are not very comfortable sharing that data because people don't want their healthcare data to be shared with people. So there is a trade-off, and it has to be navigated very carefully. So IT security wise, whatever steps people take to maintain the privacy of the data, they should take, like we don't take any data without any routing the connection through VPN. VPC. There are a lot of uh, there are a lot of solutions IT wise, like which can help you maintain that privacy and help you in the way that the data doesn't reach to wrong hands and it's not misused. So that is one, that is age old, not age old, but it's the traditional solution for data privacy. uh, in that there is also anonymization, which is also a traditional solution, right?
Right.
So but going forward, like a lot of people have been moving to redaction. And redaction is basically wherever you find the data which is questionable, you redact it, or you draw a dark bounding box around that data, and you leave the other data as it is. So that is gaining a lot of significance in the market. A lot of people are trying to adopt it. And so manual is easy. Manual, you create a application and people can just redact it, but it's time taking. So people are moving to automated redaction. And automated redaction requires you to first find the entities to redact. So that is a machine learning problem. But once you train it, then you can use it on any data set, any PDF file. So that is keeping that in mind, we built our redaction module in text.ai, and we have the maximum number of clients right now for redaction. And one of the large companies that we're working with, their use case is redaction. We have built an automated redaction module, deployed it as a SaaS module for their use case. It is a electronic medical record compliant with HL7 rules, and we are doing redaction in an automated manner for them. They have average flow of around 200 to 300,000 records a month, which we are redacting for them.
Excellent. So what seems to be the problem is also there's an opportunity, and AI and specifically text analytics is solving, making less headaches for government and agencies. Now, Ashish, would you agree that in the last few years, from the time text analytics has been there, simultaneously AI technology has also improved in various ways? And if it has, how have we used in some of these developments in the AI and NLP in text.ai?
Yeah, so AI, ML, NLP is ever evolving. Like every month you have a new state of the art solution, especially in NLP and the audio data. There is every few months there's a new framework which is outperforming the previous framework, and that is because the research is happening on both ends. Like research is happening how more and more data can be processed. So to improve a model, right, the performance of a model, you can do only two things. One, you can increase your data. Like that will certainly give you better results. You keep increasing your data, it will give you better results. Second thing that you can do is you can make your model more complex. Like you had 10 hidden layers, you make it 100 hidden layers. It will take you more time to train, but it will outperform the previous model. So because computing is becoming cheaper and cheaper, the people are not shying away from trying both these things. Increasing the complexity of model and increasing the data for whoever has that much data. So there have been a lot of new innovations. Like there are 2 years ago, it was Elmo. Elmo was the best known word embedding method That was there, and then it suddenly it moved to BERT, like, which was a transformer based model. And the transformer is the state of the art solution right now for many things. It started from NLP, uh, and now it is being used in computer vision problems as well. So and a lot of these frameworks are open source. There's a company called Hugging Face which creates a repository of all these pre-trained models that can be used for transfer learning. So how we use these innovations is, as I said, a lot of these are open source frameworks, like the neural network architecture and all that you can replicate using tools like TensorFlow, PyTorch and all. So we use these frameworks a lot. For example, voice to text model that I told you about, we used open framework called Wave to Wake for training the model very quickly. I think if a company has to operate in NLP, try to build solutions, they have to keep an eye on all the developments very keenly. Like, a lot of innovations are happening, and we are using most of them.
Right. And would you be comfortable sharing any case study, something interesting that we have done on this area without revealing too much about the client? Is there anything interesting that you would like to share with the listener?
So I think, as I was telling you about, I could tell you about a redaction use case, but I think this audio interaction thing that we are processing, that's a very interesting use case, because there we are creating end-to-end solution, starting from patient-doctor interaction, and transcribing it to unstructured text first. Then we are diarizing it. Like, diarizing means just you can say a sort of subtitling. Like, at this point patient is speaking, and at this point doctor is speaking, and then it's like a conversation. So you have to have a model for transcribing, you have to have a separate model for diarizing, and so that is our initial output. And then we once we have the transcribed text, we do a lot of NLP processing on that to find the sections where we first filter out non-useful segments, like where people are just having a small talk. So we filter that out and keep only the relevant content. And then we structure the section where they're talking about medical history, where they're talking about earlier diagnosis, then they're talking about present illness, and then prescriptions and recommended diagnostic tests. So it becomes very structured, and we are using a lot of NLP based entity detection for doing that. And after that, we are bringing in their data as well. What is the name of the patient, demographic data, and the data of the doctor. So it becomes a complete report. So starting from an audio interaction to a complete record, which can sit in a database and can be fetched whenever needed. So that's very useful for them. And another reason why it is interesting is the scale at which we are building this for. So we have built a full scaling strategy for this application with many cloud engineers. It is fully set on Google Cloud Platform, and we are using the streaming solutions of GCP, as well as Kubernetes engines, so that it scales. And the way we process around 500,000, we aim to process around 500,000 records such interactions over a week.
Wow, that seems a big in number. Now, I was about to ask, where is this evolving? I mean, where is this going to? I mean, you said so much is happening from the technical side, is that there's always a new framework coming up. But in terms of overall application on, because we are talking about healthcare and life sciences, where do you see this space evolving in the coming years?
Yeah, good question. So I have I have a hunch. See, right now the solutions that are there, they are people are trying to build generic solutions. Like it should be applicable to every use case, right? That's what people have been trying to build. So it relates back to the first question that you had asked, like why is it adoption rates are not that high? Because everyone is trying to build a generic solution, and that's a thought process which can be which is understandable, because everyone wants the whole market. They don't want to reduce their accessible market size, right? So they want to cater to all the solutions. Right? But as we discussed, it's tough to build, right? For whatever reasons, like too many use cases, too less data. So where I see this going is, and where I have seen successful solutions or companies, not companies, but successful solutions I have seen are very custom solutions. Like there's a saying in product world that before becoming everything for everyone, you have to become something for someone.
Yes, absolutely.
So that's what I really believe in. Like, and I think most successful solutions would come if people would focus on a very niche use case. Like let's say you choose health insurance, and you say you want to build end-to-end around insurance claims processing, health insurance claims processing. That you give me a claims processing document, and I will give you all the details in a structured format. So I think that kind of niche, very niche solutions would scale and would be successful, is what my hunch is. Because you see that from other SaaS products, right? One is very easy to build SaaS products like that if you define your niche. Right? And SaaS products by definition mean that it has to be ready for the user from the word go.
Yeah.
So that can happen only if you define your niche very clearly. So I very strongly feel that that is the direction industry would go.
Excellent. Thank you, Ashish. A lot of use cases and a lot of less data, and niche development is the way to go, right? Some of the key messages that I'm taking from this discussion. Well, thank you, Ashish. That brings us to the end of this podcast. Thanks for being on the State of Text Analytics podcast, and for all the interesting thoughts. Folks, if you're enjoying this discussion, please share it with the network, and have a great one ahead. Thank you.
Thank you.
Thank you for listening to Text Analytics 201. And stay tuned for more such conversations. For more information on Indium's text.ai, visit text-ai.com.